right. Okay. Hello, everybody. So, for today's session, we will be talking about developing secure and reliable CI/CD pipelines for the cloud infrastructure. Now, the angle that I have chosen for today's session is through the lens of GitHub Advanced Security. This is the offering available for both GitHub ecosystem, the GitHub Actions or GitHub Enterprise, and this offering is also available for the Azure DevOps workloads as well. So if you are using either of the two sort of setups, you can use GitHub Advanced Security to secure whether it's your Azure repo or Azure pipeline, and similarly, you can use the same setup for your GitHub ecosystem as well. Now, I wanted to start with sort of addressing the problem that is, what is the state of our applications today? So, we are looking at a recent research which is conducted by the GitHub data science team, and that found that the open source developers are now spending an increasing amount of time dealing with vulnerabilities, and they're actually getting not better at preventing these vulnerabilities from entering the open source projects. So if you can see the purple line here, it shows the number of commit messages in an open source project, and it also mentions the vulnerabilities over a 4-year window. The blue line shows the code which gets added to the same open source project, and then the red line shows you the number of security threats which are added to those particular projects. So as you can see, the correlation between the code size and the security threat is very strong, which indicates a consistent introduction of the security issues. And this picture is rather a dismissal one, because we have seen that this is an increasing trend. And with the amount of time, more and more vulnerabilities will be introduced, which will also go ahead and affect the security issues, not in the open source projects, but also in our repositories, also in our pipelines.
Priya, I think like the screen that you're sharing, you're showing like the first PPT slides, not the other slides.
Okay, so I'm at the state of AppSec. Can you see that or no?
No, we're just seeing like the first slide.
Okay.
We can see your mouse. Yeah. So if you can
So now
check.
you can see all these slides, right?
Yes, that's work. Thank you very much.
Okay, all right, perfect. All right, so this was a slide that I was talking about previously, which is that we have seen an upward trend. Now, for the next slide, so if I'll put it in the PowerPoint mode again, let me know if you can see the slide now as well. Is it still visible or?
No, well, still like on the PPT itself, not like full screen.
Okay. And now you can see all the slides, is it?
Yeah, we can see you clicking through them. Yeah.
Yeah. So, sorry, is the state of the AppSec visible to you now? The one that I'm currently on?
Yes, that's working well. Yeah.
Apologies, everybody. Let me first fix this. Sorry. I am currently uploading my slides, so you should have that now. Is it working, everybody? If you can just give me. All right, I'll just move along. Right, so I was talking about the AppSec and how we are sort of facing some of the challenges with the increasing of the code. Now, it is easier said than done. What we have understood is that we can, um, how we can empower our developers to actually fix the bugs, to actually have less number of breaches, specifically from the credential breaches as well. And at GitHub, what we are trying to do is we are trying to bring into the understanding of how there is the lack of the improvement in the world where development is transforming so quickly in a wonderful way, but the security is not simply matching up to that. And there are three areas where we see that biggest gap, specifically around the developer and the security team. So for sometimes the ratio is 1 is 200. So while you have the goodness of the DevOps, which is making your supply chain and everything go in a very faster way, you have security teams which simply can't keep up with that. Lack of knowledge voted the main AppSec challenge. So we do have a certain sort of skill gap, which really requires for us to have more sort of DevSecOps people, which brings the three ecosystems together and sort of lessens the silos that are existing at the moment between the three. And then it's also about the kind of tools that in the past that we have been using. So we are coming from sort of old methodologies when it comes to the security aspect, specifically in our DevOps cycle or a CI/CD cycle, right? We are using some of the tools which does not gives us the correct sort of pinpoint that this is exactly the issue is happening. Sometimes to get to the issue, it takes about 6 to 7 hours, and then the whole charade begins to actually go ahead and remediate the issue, which in itself can take several days or weeks or even months. So we also need to sort of combine the tooling aspect of it, which can not just give us proper alerts and everything or a bird's eye view as to what exactly is happening in our environment, but can also help us to pinpoint in the right direction so that the remediation can occur in a faster manner. Now, I've included this slide to just go through very quickly that what does CI/CD pipeline means. So now we know that CI/CD is largely the set of automated processes, which is to build and deliver the software. It is often portrayed as the pipeline, which consists of a series of sequential and discrete steps. So if everything comes together, you have CI, which is continuous learning, and then CD, which is continuous deployment. So you have the two worlds coming in together with different sort of phases. And this is extremely important because with the entire left shift of the security, what we are trying to introduce, the security aspect of it each and every step, which always used to be a fifth or a sixth sort of step approach, but now it's slowly moving or making its move towards a direction where what can we do to sort of have a secure supply chain through and through our CI/CD pipeline? What can we do to make sure that right from when our developers are writing the code in their plugins or IDEs, whether it's Visual Studio Code or anything else, they have those secure channels, which does not really sort of introduces vulnerabilities at a later stage, or if a vulnerability is caught, could be an SQL injection, could be a security breach, could be third party packages which are impacting your pipeline, which your developers might be using, or your dev and ops people might be using. What can we go ahead and do to a have a preventive methodology, and then of course to remediate them in a faster way? Some of the challenges of CI/CD, and I'll also go through it very briefly. So, some of the challenges of the CI/CD is the increased attack surface. So, as we know, as we have seen that as the sort of ball gets rolling on more and more open source project, we'll see there will be an increase in the attack surface as well. The intricate nature of the CI/CD pipeline, which actually involves multiple tools, multiple stages, integrations, and adds complexity to your security management and monitoring, there is a requirement of having high privileges. There's also an requirement of sort of having a cultural shift as well to understand that the security aspect is also necessary for the developers as well. There's also compliance challenges, and there's also a need of continuous monitoring as well. Like I said, we have been using traditionally lots of tools, and sometimes there isn't a single dashboard, or sometimes there isn't a single source of truth which you can go ahead and look for to understand probably this could be one of the sort of issues that has been happening and can get to the remediation in a faster way. The GitHub difference, and like I said, I'll talk about the angle of CI/CD pipeline. There can be many angles and there are many tools available, but internally, what we sort of recommend for all the customers who are using Azure DevOps or you're using GitHub enterprise system is GitHub Advanced Security, because this actually sort of captures all the ethos of the different phases of CI/CD pipeline, whether it's your secret management, whether it's code scanning, whether it's dependency scanning, dependency scanning, which basically means third party scanning, direct or transitive. It sort of emboldens itself into the entire pipeline cycle of the Azure DevOps and sort of affiliates itself with all the components. So, what is the GitHub difference? The first is the native. So, it is embedded from init to ship, it's automatically deployed. There is a visibility into the security posture across all code. One of the things that I wanted to mention here is that our ecosystem, the GitHub Advanced Security ecosystem, is just a part of the AppSec or a CI/CD pipeline secure thing, right? We have several other tools such as Microsoft Defender for Cloud, which integrates with these tooling perfectly well. So you can leverage different sort of tools within the Microsoft's ecosystem, like let's say Microsoft Defender for Cloud or Azure Sentinel, to actually get that bird's eye view as to what exactly is happening in the environment. And then for very specific DevOps or CI/CD based workloads, you can leverage GitHub Advanced Security. Trust by design. So there is supply chain analysis, there is secret scanning, there is security lab, it's an extensible platform, and you also have static code analysis. So a bit about the supply chain analysis. So we give you the dependency graph. So your sort of repositories or pipelines might be using some third party packages. Now that could be a direct package, which you know what sort of package you are using, but then within that package you are not sort of aware that it could be using any other third party sort of packages which may or may not have its vulnerabilities identified. So to be able to capture both the direct and the transitive packages, we have a dependency graph, which sort of gives you a graphical representation that this is your package. It sort of depends on this. This further depends on this. So you have a complete mapped picture in front of you to understand that exactly this is what is happening, and you can stop something which classifies itself as to be vulnerable there and then. Fixing in minutes. One of the aspects is this: to have an alert generated, to have proper monitoring channels, and to have the alerts generated so that right away, if any issue is encountered, if there is any particular problem, then you always have some or the other methodology to go ahead and get to the right source of the problem. Jargon free language and automated fixes. And then community driven. So this is constantly getting evolved, constantly new things are getting added onto this particular platform. It is supported by a million of developers and security researchers, so we do get sort of contributions, and also it also gets sort of its contribution internally from Microsoft as well. The first service within this ecosystem is Dependabot. So what does Dependabot means? Dependabot is basically a service within the GitHub Advanced Security that you can leverage. Once you have your repository created for a certain particular project, now this could be again in the GitHub ecosystem, or this could be in your Azure DevOps as well. So this is applicable at the repo level. This can be applicable at the pipeline level as well. So once you have your repo created, all you need to do is you need to go to that particular repository and you need to enable the Dependabot. There are some differences in private versus public repo. So for public repo, you have certain services like Dependabot, code scanning, secret scanning, which precisely we are discussing today, already enabled. There are some coveted services like security advisories and other things which only sort of can be leveraged if you have certain enterprise channels. But if you are using a private repository, it would really depend on how you can go ahead and enable it. There would be some sort of enterprise things that you have to look after. But for all the public repositories, you would have dependabot code scanning and secret scanning, which you can start leveraging right away. So within Dependabot, you have two sort of aspects. You have the dependencies, direct and transitive. So direct would be the direct dependencies that your repositories is reliant on, and then the indirect would be the transitive ones. So it will go ahead and have the automated pull request for security and version updates. So you will be able to keep your projects secure, up to date by constantly monitoring them. So you'll have to enable it at the pipeline level and making sure that if there is any vulnerability, if there is any out of the date component, it will suggest you to go ahead and update to a latest package. And then it will go ahead and automatically open a pull request with the suggested fixes. So you can just go ahead and simply go ahead and do the fix. And that should go ahead and fix the issue for you. Now, I will show a demonstration very briefly in a couple of minutes of all these three services as well. Then it integrates with your developer workflow, so it can be directly integrated to your developer workflow for a frictionless experience. And it also tracks the vulnerabilities in the packages from supported package. If you'll go to the github.com link for Dependabot, you'll see a series of packages it supports, like it could be pip or it could be nmp. So you have all these packages that it supports. So if you are using these packages, we have internally something called as GitHub Advisory Database, which basically captures all the data from security researchers and maintains it in the national vulnerability database. It postulates all its vulnerabilities from there, and based on that, it sort of correlates your package. And if there is any vulnerability found, it basically flags off it to you that this is the one thing which would require the package to get updated. Then we have code scanning. So this is the aspect of having proper code signing and code scanning done right at the very first level, where your developers are basically creating the code, or they're trying to go ahead and write a sort of code without any poisoning or without any sort of adding on to any vulnerabilities. So the language or the base tool that it uses is CodeQL. So CodeQL language or query language is basically used, which does all the scans and then fixes the vulnerabilities that are merged into your code. By the virtue of it, it can also check your syntax. So if there are any syntax challenges, you can also go ahead and get that corrected as well. You can enable it in the Visual Studio Code, and if you're using code bases within GitHub, it can also be used directly therein as well. Again, it is integrated with developer workflows, so you will have results directly into the developer workflow for a frictionless experience. So if you things like SQL injections or anything else can be taken care of through the code scanning. And then community of the top security experts. So it is powered by lots of security experts who are already using the queries which are created by the security community in your project. So you can leverage all the goodness of the world class security team stuff that they have been doing. And then we have secret scanning, which is again to reiterate the messaging that although we do understand that poisoning of the CI/CD pipeline, or sort of targeting or attacking the CI/CD pipeline, could be some very high tech savvy stuff, but at the bottom line, 80% of the cases would be simple credential breach. So you will find that a lot of credentials are not very secure, or if there are any vulnerabilities that already exist, they're not really taken care of. So we need a proper secret management sort of tool which can help us to identify the secrets as early as possible. So the moment they are pushed into GitHub, and immediately the developers are notified that this is what they have found, this would be some of the pattern that they have recognized in your code, which could be very sensitive information that is already available, and it will not let you do a pull request unless you fix that particular issue or that particular security scan which has sort of flagged up. It supports both public and private repo, so it watches both public and private repo for the potential secret vulnerabilities. And then it also scans for patterns that are internal to your organization across your repository. So if you are using sort of private repositories internally, then you can define custom patterns which are pretty much internal to your organization and across to the repositories. And then for every commit made to your repository and its full Git history, we will look for all the secret formats from secret scanning partners. So let's say that you have done a commit in your repository. Whatever has been the full Git history of that repository, the secret scanning tool will check for all the secret formats from the secret scanning patterns, which are available again through the famous packages, and we'll be able to go ahead and tell you that, look, this would be sort of the problem, and then this would require a fixture or something needs to be fixed from your end. So with secret scanning, you also get something which is called as push protection. Again, push protection is something which you can leverage, or it depends on you. You'll have to go ahead and enable it again at the repository level. But through push protection, what we can do is we can basically get the leaks to the users on push. So again, it applies to all the repositories with secret scanning, and the push protection gets enabled on them. So it can detect potential secret patterns at the push time in your repositories. It can also be used to detect the potential secrets in the repositories with secret scanning alerts enabled. And it can also help you to sort of identify any leaks that you have been sort of having in your repositories. So these are the three main services that we usually talk about when we talk about securing our pipelines. Now, this is just a version of how I would define a in a DevSecOps platform. This is just a version of what we do for DevOps. The SecOps part of it, which is how we can have more reliable and secure operations, whether it's CI/CD or the entire DevOps cycle, we have other tools that this integrates with. So if you want to get an automated alert management, or you want to get the overall view of how your entire DevOps cycle is happening, you can use Defender for DevOps, or you can use Microsoft Defender for Cloud. So you have all these services as well that we can go ahead and leverage along with GitHub Advanced Security to basically see if we have a secure CI/CD pipeline or not. I will now show you a demonstration very quickly. So I'll just stop sharing my screen, or let me do one thing, I'll present it. Hopefully you can see my screen now. So I will just go ahead. So you can go to your GitHub and you can just select any of the repository that you want to select. I will select this repository right now. To enable GitHub Advanced Security, what you have to do is you have to go to the Security tab. Now, I already have this enabled, but you can see that you get all these policies, all these security tabs in here. You get security policy, you get security advisories, which is also enabled. You also get private vulnerability reporting. You get Dependabot alerts, which I was talking about. You get code scanning alerts, and then you also get secret scanning alerts. And if you see the three main services, you have Dependabot, you have code scanning, and then you have the secret scanning as well. If I go to the Dependabot scanning, it shows me there are 4 open Dependabot alerts that it has identified. If I just go to this one, it shows me that the code URI component vulnerable to the denial of service. And then it also suggests me a security update as well. If you can see on the right hand side, it gives you a severity based rating as well, that on the basis of CVSS space metric, what could be the severity of this, and it's 7.5/10 for this particular Dependabot alert. It also gives you some of the some of the more details around it. So you also get attack vector, attack complexity, privileges required, scope, confidentiality, integrity. And then you also have the option of dismissing the alert. If you think it's a false positive, it doesn't really concerns you, you can also dismiss the alert as well. I'll just do a review of the security update, and I'll say, yeah, I agree to it. And I'll just click on the merge pull request and confirm merging. And that's it. That's all you have to do. Go ahead and do. It will basically go ahead and resolve that issue. And now you have a newer version of the vulnerability that has been identified, and it fixes your problem. So it is pretty straightforward to get started with the different sort of security aspects of it. If I go to the code scanning, you can see all of this has been some of the flagged code scanning alerts it has generated based on the code that I have. If I go to this one, it says to me that inefficient regex, so inefficient regular expression. Again, it gives you the error message as well, that this part of the regular expression may cause exponential backtracking on string starting with this one. So then it again depends on you if you want to go ahead and fix that. The severity is high for this particular thing, and then it also gives you sort of what are the affected branches. And then you also have the similar aspect for the security as well. And with that, I'm being very cognizant of the time. We are almost at the end of our session. Thank you all for listening in. And hopefully, the key takeaways from the today's session would be that how GitHub Advanced Security functions, what are some of the important pillars, whether it's depend-abort, code scanning, secret scanning, and how to get started with that in your own GitHub repository, and pretty much applying the same concept if you have any Azure DevOps-based workloads as well.
Thank you very much, Priya. It's interesting. Like I've been using the GitHub Advanced Security. I think like even like the public repositories, I think they're very handy, right? Just to
Yeah,
pinpoint some sort of vulnerabilities, right? That's available in your codes. What I have not explored is the Azure um, Defender, right?
right.
What 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 would be like the I would say the main aspect, right? Because like I've been using a lot like Azure DevOps, right? And we
Yeah,
don't have such implementation as available on GitHub. So how
yeah,
we could have some similar um, use case for that, leveraging uh,
right.
Defender.
Yeah. So if you think from the Azure DevOps lens, you'll have to enable all these services independently. And then if you want a common sort of area to get all the alerts or all the sort of things that are happening in your DevOps pipeline, there might be too much that you have to do at the Azure DevOps level, right? You have to go to each and every pipeline to see what exactly is happening and then remediate from that. If you are using Defender for DevOps or Microsoft Defender for Cloud, you do get that single dashboard. So you do get the amalgamation of everything into that one flavor, which can direct you or have that methodology that, look, this is the alert which is happening, and you go right to that particular alert and fix that problem instead of having somebody to keep an eye on what exactly is happening at the every pipeline level, which is a very good useful use case because you want it to be automated as much as possible instead of just going. If you are an organization which has, let's say, lots of pipelines, it would be somewhat become very cumbersome if you have to go through each and every pipeline because there is a no
Hmm.
unified platform that you get, which is what we do it through the Azure Defender.
I see. Oh, yeah. No, thanks for coming like a little bit earlier. Really appreciate your time in coming to share like here with community today.
Yeah.
Thank you very much.
Thank you. Thanks all. Thank you.